Hello friends, welcome back to Pharma for You, and here we are back with our new video, properties of colloids. So let's begin with our new video. Starting with what are colloids. The term colloids implies glue-like. In Greek, it implies that they are glue-like. If we talk about general, then it is a system where dispersed particle of size range colloid. Okay, the particle, if they are very small, then they are molecular. Above than that, they are colloids, and above than that, they are coarse particles. And if a system where dispersed particle of colloid range and distributed uniformly in a dispersion system, then it is called colloidal system. If you are talking about the size, 0.5 to 1 micrometer is the particle range in which the colloid resides. So properties of colloids, there are three major properties of colloids: optical properties, kinetic properties, and electrical properties. Optical properties, actually why we need to study properties? Actually, whenever we go for a colloidal particle range, then we need to make assure that the particle range is perfect, that they are not in the molecular range or they are not in the coarse range. So we have to validate or assure after their formation that they are in the colloidal range. So with the help of their properties, we can identify that they are in colloidal range. So there is a need to study properties of colloids. So first is optical properties, kinetic properties, and electrical properties. Optical properties, under the optical properties, they are Tyndall effect, ultra microscopy, electron microscopy, and light scattering. In kinetic properties, Brownian movement, diffusion, osmosis, and viscosity. And under electrical properties, the properties are electrophoresis, electroosmosis, sedimentation potential, and electrical double layer effect. So starting with optical properties, Tyndall effect. As they are in the colloidal range, then they show some special properties. So Tyndall effect. When a narrow beam of light is passed through a colloidal dispersion, the light illuminates and it becomes scattered. And the light which is scattered, that is due to the Tyndall effect, that can be seen with the help of microscopy. And if we can classify the microscopy which is used to see the Tyndall effect, then we can use normal microscopy, then ultra microscopy, and then electron microscopy. Actually, the normal microscopy doesn't have any effect or positive result showing some Tyndall effect. So we have to go for ultra microscopy. So ultra microscopy, when a colloidal dispersion viewed through a ultra microscope against a dark background at a right angle beam, it appears as a bright spot. So it is due to the Tyndall effect. In ultra microscopy we can see a bright spot. So we can measure the diameter of that bright spot, which is a colloidal particle. So with the help of this Tyndall effect and ultra microscopy, we can determine the particle shape and particle size. Then electron microscopy, it provides a better picture of actual particle rather than ultra microscopy. That if you want an actual structure and actual size determination of colloidal particles, then we have to go for electron microscopy. Now light scattering, when a beam of light passes through a colloidal dispersion, some is scattered, it estimates size and shape of particle. So it is similar to Tyndall effect, that when a beam of light is passed through a colloidal dispersion, most of them is reflected to one direction, that is at a perpendicular angle, and rest is the scattered. So this scattering is used to determine the size and shape, that is a Tyndall effect. Now, kinetic properties. As we all know that kinetic means the movement or motion of motion of a particle, starting with it Brownian motion. The colloidal particle in dispersion are always in a state of random motion. Robert Brown has observed it first, so it is called Brownian motion. So, as we know that Brownian motion is the movement of particles, particles in a dispersion. Whenever we are going to prepare a dispersion of coarse range or colloidal range or molecular range, then specifically when colloidal particles are there, then they show Brownian motion. So Brownian motion is a random movement of particles. So they will not settle down and will scatter, and their motion will let the dispersion to be stable for longer times. Now second is diffusion. It is a movement of solute molecule from a region of higher concentration to a lower concentration until the concentration of system become uniform throughout. As we all know that the diffusion, the process in which the solute molecule move from higher concentration to lower concentration, as it is similar in all cases and in the colloidal range also. Now osmotic pressure. This property depends on the number of particle in dispersion. Number of particle denotes the osmotic pressure of any liquid. It will be denoted as P equal to C upon M RT. Fourth is viscosity. It depends on the shape of colloidal particle. The shape of colloidal particle, if they are sphere, then the properties viscosity is low, and if they are in length or height, then the viscosity may be higher. Next is electrical properties. Electrical properties, first is electrophoresis. The moment of electrically charged colloidal particle under the influence of an applied electric field is called electrophoresis. Generally colloidal particle range particle having electrical double layer over them. As we go for smaller particles from coarse particle to colloidal particle, then if we apply any energy, then this energy will be converted to an electrical double layer around colloidal particle, and this property we can use for electrophoresis. Okay, it is not in the coarse dispersion, but it is in the colloidal range. So electrophoresis is better, can be seen in a colloidal range particles. Next is electroosmosis. The movement of the dispersion medium through a porous material under the influence of an applied electric field is called electroosmosis. Electroosmosis is inverse of electrophoresis. Sedimentation potential. This is the potential difference set up between top and bottom of a suspension of solid particles in a liquid when the particles settle under the influence of gravity. So sedimentation potential may also be a property of a colloidal dispersion to identify the particle size or their weight, molecular weight, as their sedimentation potential denotes how they are settling and how the sedimentation take place and the speed of sedimentation. Electrical double layer theory. In this theory, the charge is imparted to the particle by placing ions which are absorbed preferentially at immovable points, which of the first layer. The second layer consists of diffuse mobile ions. The charge present on both the layer is equal. These two layers arrangements leads to development of potential called zeta or electrokinetic potential. As a result of this potential develop across the particle under the influence of electrical field, this particle move. As I told earlier, that when we move for colloidal range of particle from a coarse particles, then we apply a type of energy or work has to be done, and when a work has to be done, and the energy or the work which is implies on the particles, it will be converted into the charge. The charge is the electrical double layer, and this electrical double layer then can be used for electrophoresis and electroosmosis. So thank you for watching this video. You can like, share and subscribe our video, and for more information you can visit our website Pharma4U. Thank you so much.